So what we're going to learn how to do is how to graph absolute value functions. And if you were asked to graph the absolute value of negative x plus 4, you could think about the inside negative x plus 4 is a line with the slope of negative 1. It would have an x-intercept at 4, y-intercept at 4. It would look like, wow, make a really big dot. There we go. This is the line y equals negative x plus 4. Now, what do the absolute value bars do? They say after you've simplified, it'll make things positive. So if I plugged in 0, I would get 4, and if I did the absolute value of 4, I would still get 4. Oh, here, I can hit one button and all those numbers will appear for me. Maybe, or maybe I can't hit that button. If I plug in 2 into this, I'd get 2, and the absolute value would be 2. But this number right here, if I plugged in 6, I get negative 2. But if I plug in 6 into the absolute value one, that negative 2 would become positive. And the idea is that this whole part, can you see, just got reflected up to become that part. And the idea of reflecting it up is because you are multiplying your y values by negative 1 to make them positive. But you only do that when your y values are negative. So a very important point is this one. And if you take out your highlighter, we call that a critical point because that's where it changes direction. So let's go to example 1. And it says, sketch the graph of 3x plus 6. So what I'm going to do first in blue is I'm going to graph just a regular 3x plus 6. I know that my y-intercept, 1, 2, 3, 4, 5, 6, is at 0, 6. I know that my slope is 3 and it's positive, so I can either go up 3 over 1 or down 3 back 1, down 3 back 1. And I really want to find my x-intercept, which happens to be at negative 2, 0. I found my x-intercept by using the slope. I could also find my x-intercept by plugging in 0 for y and solving for x. That x-intercept is going to be important because when I want to, and I'll do it right beside here, when I want to sketch the graph of the absolute value of 3x minus 6, well, what does the absolute value do? It makes things positive. So, for example, 0, 6 is still going to be 0, 6. It's not going to change that. Negative 1, 3 is still going to be negative 1, 3. Notice, what's getting the absolute value is the y value. So the negative 1 for the x, that's fine. You can plug in negative 1 for x, you will get positive 3, and the absolute value of positive 3 would stay 3. And very important will be this critical point at negative 2, 0. But on my blue graph, I would have the point negative 3, negative 3. And on the green graph, I would have the point negative 3, positive 3. And the section that was below the x-axis is the section where the y values are negative. That section is going to get reflected up over the x-axis because you're going to take each of those y values that were negative, and now you have an absolute value that would make them positive. So identify the intercepts. We've already done that on our graph. The domain and range of this function. There's no non-permissible values. The domain is everything. And our range is now bigger than or equal to 0. All of our y values are positive. You can circle 4, 5a, 6, and 7a, and 10a and b.